Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 4.2, which is going to deal with transversals and parallel lines. Now, for today's lesson, we have one learning goal, and our learning goal is you will be able to identify an angle relationship formed by two parallel lines cut by a transversal. So, angle relationship means a relationship regarding two angles, like vertical angles, complementary or supplementary. Just today we're going to be taking a look at some different situations, and we're going to use those properties of the relationships to find angle measures. So today we're going to see a lot of diagrams drawn like this off on the right. Most of the time you're going to hear it phrased like this: two parallel lines cut by a transversal. Lines P and Q are going to be considered my parallel lines, and line T is going to be my transversal. Transversal is just a fancy way of saying a line that cuts through two lines, forming this diagram. Now, as you can see, my two parallel lines cut by a transversal form 8 different angles for our diagram. Now, what we are going to do today is take a look at 4 different relationships based off these angles right here when you have two parallel lines cut by a transversal. So first thing we're going to do is identify and talk about what those 4 different relationships are, and then talk about what those relationships result in. So first angle pair is going to be corresponding angles. Corresponding angles are angles that lie on the same side of the transversal and on the same side of the intersecting lines or the parallel lines. So corresponding, same side of the transversal and same side of the parallel lines. If I look at an example, would be angles 1 and 5. Angles 1 and 5 are here and here. Oh, I covered that up. So angles 1 and 5 are corresponding angles. That means that these two angles are on the same side of the transversal, so they're on the left side of the transversal, and they're on the same side of the parallel lines. So left side of the transversal, and they're going to be on the top part and top part. So 1 and 5, left and up, left and up. So angles 1 and 5 are an example of corresponding angles. Now, as we go through our notes, we're going to identify 3 other sets of corresponding angles. Next, same side interior angles. Everything after corresponding, the name tells you the location of it. So same side interior lie on the same side of the transversal and in between the parallel lines. Example would be angles 3 and 6. Angles 3 and 6 are on the same side of the transversal, so they're on the right side of the transversal, and they're in between or interior of the parallel lines. So they're in between the parallel lines, and they're on the same side. So angles 3 and 6 are same side interior. Next, alternate interior angles are angles that lie on opposite sides of the transversal, but still in between the parallel lines. And an example of that would be 3 and 6. So alternate interior, if we're looking at 3 and 5, sorry, I meant 3 and 5. Angles 3 and 5 are alternate interior. They're on alternate sides of the transversal, and they're still in between the parallel lines. So 3 and 5 is an example, and 4 and 6 would be another one. Alternate sides, opposite sides of the transversal, but in between the parallel lines. And then our last relationship is going to be alternate exterior. They're on opposite sides of the transversal, but outside the parallel lines. Meaning, an example of that would be angles 1 and 7. 1 and 7 are on opposite sides of the transversal and outside the parallel lines. Inside would be these ones, outside would be on the top and bottoms. So angles 1 and 7 is an example of alternate interior. So those are the 4 different angle relationships we're going to talk about today. Now, most of the rest of our notes is talking about other examples of these 4 and what they result in. So what is the result of the relationship? Meaning, what do they equal? What do they add up to? And such. All right. Let's first take a look at same side interior angles. All right. Same side interior angles postulate states if 2 parallel lines cut by a transversal, then the pair of same side interior angles are supplementary. Meaning, same side interior angles are supplementary. What does supplementary mean? Well, if you think back to what we talked about yesterday for section 4.1, supplementary means that they add up to 180 degrees. So when you have 2 angles that are same side interior, that means that they add up to be 180 degrees. Now, and I can get this to come over, there we go. What it wants us to do is to indicate and list the same side interior angles. So, same side interior angles would be angles that are on the same side of the transversal, but in between the parallel lines. So, the examples of that would be angles 3 and 6. And angle 4 and 5, because they're on the same side of the transversal, but in between the parallel lines. Meaning, angles 3 and 6 add up to be 180, and angles 4 and 5 also add up to be 180. Same side interior are supplementary, so these pair, 3 and 6, 4 and 5, are supplementary, and they add up to be 180. If I knew, let's just say for example, that angle 3 was 130 degrees, that means I would know that angle 6 is 50 degrees, because these two have to add up to be 180. So if I know that angle 3 is 130, that means angle 6 has to be 50 degrees. All right, same side interior is supplementary, and that's actually going to be our only one that's supplementary for today and moving forward. Same side interior, supplementary. Same side of the transversal, in between the parallel lines. All right, next, we are going to take a look at alternate interior angles. The alternate interior angles theorem states, if 2 parallel lines are cut by a transversal, then the pair of alternate interior angles have the same measure. Meaning, alternate interior angles. Whenever you have 2 angles that are alternate interior, means they have the same measure, which means they are equal to each other. Now, it asks us to go through and indicate and list the alternate interior angles based off our diagram. Off of this diagram, the set of alternate interior, remember alternate interior is their opposite sides of the transversal, but still in between the parallel lines. So we're going to go through and ignore outside the parallel lines, and we're just going to focus on angles 4, 5, 3, and 6. Now, we're talking about alternate interior. That means they need to be on opposite sides of the transversal, but in between. So that would represent angle 4 and angle 6, and then angle 3 and angle 5. So for our case, the alternate interior angles are angles 3 and 5 and 4 and 6. They're on alternate sides of the transversal, but still in between the parallel lines. Now, these angles are equal to each other. So 4 and 6 are the same measure, 3 and 5 are the same measure. Meaning, if I knew that angle 3 was 130 degrees, that means angle 5 is also 130 degrees. And if I knew angle 6 was 50 degrees, that means angle 4 is also 50 degrees. So 3 and 5 are alternate interior, meaning they're equal. Same with 4 and 6, and they are equal to each other. Next, we are going to take a look at the corresponding angles theorem. Okay, corresponding angles. If we have two parallel lines cut by a transversal, then the pair of corresponding angles have the same measure. So corresponding angles are the same measure, which means corresponding angles are equal to each other. So when you have a set of angles that are corresponding, that means they are the same measure to each other. Now, let's talk about the different examples or set of corresponding angles based off this diagram. First, corresponding angles are on the same side of the transversal and then the same location on the parallel line. For example, if I look at angle 1, it's on the left side of the transversal and above the parallel line, while angle 5 is on the left side and above the parallel line. So angle 1 and angle 5 are corresponding angles, as are angles 2 and 6. Then we also have angle 4 and angle 8 because they're on the left side but below the parallel line, left side below the parallel line. So 4 and 8. And lastly, angle 3 and angle 7. So all of these are the different corresponding angle pairs that we can use, and corresponding angles are equal to each other, which means if I know that angle 2 is 50 degrees, let's say that angle 2 is 50 degrees, that means I know angle 6 is also 50 degrees. And you can do the same thing for 1 and 5, 4 and 8, 3 and 7. As long as you know one of the angle measures, you can go through and find its pair by using the corresponding angles theorem. All right, the last theorem we're going to take a look at is the alternate exterior angles theorem. Now, alternate exterior angles states if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles have the same measure. So alternate exterior angles are equal to each other. So if you know you have a set of alternate exterior angles, that means that you know they are equal to each other. That means they have the same measure. All right, alternate exterior angles. They're on alternate sides of the transversal, but on the outside part of the parallel lines. That means we're going to ignore those angles right there. So if we just kind of ignore in between the parallel lines, we're going to focus on angles 1, 2, 8, and 7. because they are exterior or outside the parallel lines. Now, our set of alternate exterior angles would be angles 1 and angle 7. And angle 2 and angle 8. So angle 1 and angle 7 and angle 2 and angle 8 are our set of corresponding angles. What this means is, let's say I know that angle 7 is 140 degrees. That means I know that angle 1 is also 140 degrees. Alternate exterior have the same measure. All right, now we're finally going to get into some examples for today. Using these 4 different angle relationships, what I would suggest you do is you really would be helpful for you to have completed notes up or to have them right next to you as you go through and do the homework. So let's get into example 1. Now, example 1 is going to ask us to identify the angle relationship and use the properties to find the value of x. So what we're going to do is take the expression that they give us, or the 2 parts that they have told us, and we're going to use those to find the value of x. All right, for part A, we have 5x minus 10 and 50, so that refers to this angle and this one. The first thing we need to do is identify what angle relationship those 2 angles are. So they are in between the parallel lines. So it's going to take us to one of the interior theorems. And because they are on opposite sides of the transversal, that means this is the alternate interior angles. So these 2 angles are alternate interior angles. And if you think back to what we talked about with the alternate interior angles theorem, that means that they are equal to each other. So we are going to take these 2 and set them equal to each other to solve for x, which gives us 5x minus 10 equals 50. We're going to go through and then solve for x. Just use our basic algebra skills. We add 10 to both sides. We end up with 5x equals 60. If we divide by 5, we do 60 divided by 5, we get x to equal 12. And that is how you're going to go through example 1, part A, B, C, and D. Now, I am going to run through all the parts just so that way you hear me explain what type of angles they are and what to do. If we look at part B, for part B we have 10x minus 5 and 8x plus 9. So if we look at these 2 angles, they are on opposite sides of the transversal and they're outside the parallel lines. So opposite sides implies alternate, and then because we're outside, that's going to be exterior. So these 2 angles are alternate exterior. So if they are alternate exterior, using the alternate exterior angles theorem, that means that these 2 angles are equal to each other because they have the same measure. So we're going to take 10x minus 5 and set it equal to 8x plus 9. We're going to go through and solve for x. So I'm going to move 8x to the left. We get 2x minus 5 equals 9. I'm going to add the 5 to the right. We get 2x equals 14, because 9 plus 5 is 14. And then divide by 2. 14 divided by 2 is going to give us 7. Meaning x equals 7 for this situation. All right, let's move on to our last two parts for the notes today, which is part C and D. Again, we want to go through and identify the angle relationship, and then using that angle relationship, go through and find the value of x. All right, let's take a look at C. For C, we have 20x and 17x minus 5. These two angles right here, they are on the same side of the transversal, and they're in between the parallel lines. So same side of the transversal, and then in between my two parallel lines. Knowing that, that is going to indicate that they are same side interior angles, because they are on the same side of the transversal and in between the parallel lines. Now, the same side interior angles theorem, which we talked about on the front side, states that these two angles add up to be 180 degrees. Meaning, I'm going to take 20x plus 17x minus 5 and set it equal to 180. Again, same side interior is the only one where they add up to be 180. So keep that in mind. The other three are equal to each other. So if we go through and solve this for x, we're going to combine like terms, and we end up with 37x minus 5 equals 180. If we add the 5 to the right, 180 minus 180 plus 5, it's going to give us 185. So we have 37x equals 185. And then if we divide by 37, 185 divided by 37 gives us x equals 5. And that is our answer for part C. All right, last one for part D. For part D, we have 6x minus 4 and 14 plus 4x. These two angles, they are on the same side of the transversal and on the same spot of the parallel lines, meaning these are corresponding angles. And corresponding angles, what we talked about in the corresponding angles theorem, they have the same measure, which means they are equal to each other. So we're going to take these two expressions, 6x minus 4, and we're going to set it equal to 14 plus 4x. So we're going to go through and solve this. We would move the x to one side, so I would subtract the 4x to the left. Giving us 2x minus 4 equals 14. I add the 4 to the right, giving me 2x equals 18. And then I divide 2 to both sides, and I get x to equal 9. So, knowing that these are corresponding angles, I know that they are equal to each other. So I take both of these expressions, set them equal, and I get x to equal 9. All right, so that is it for example 1, and that's going to be most of what you see today. And that's really our only example for today. Now, I quickly want to go back here at the start and just talk about this real quick and sum it up. So, at the start of our lesson, we started talking about these different angle pairs. We talked about corresponding angles, same side interior, alternate interior, and alternate exterior. Corresponding angles are equal to each other. Same side interior are supplementary, so they add up to 180 degrees. Alternate interior are equal to each other, and alternate exterior are also equal to each other. All right. That is it for section 4.2 on transversals and parallel lines. If you have any questions, by all means, either shoot me an email or ask me next time you see me, and I'll be more than happy to help however I can. That is it for our video lesson today. If you have any questions, just let me know. Otherwise, that is it, and I hope you have a great day, and I'll talk to you guys later. All right.